Welcome to Math is Beautiful. In this video, we see why the fundamental theorem of calculus works, how accumulated area and rate of change turn out to be two sides of the same coin. Why does the fundamental theorem of calculus actually work? Today we watch slopes and areas, two total strangers, turn out to be the same story told twice. Here is a function f, drawn as a curve. Calculus has two big machines. The derivative eats a curve and reports slopes. The integral eats a curve and reports areas. They look like strangers. Slopes and areas have nothing to do with each other, or so it seems. Here is the bridge between them. Fix the left end at 0, but let the right end slide. Call I of x the area collected so far up to position x. Slide x right and I grows. I is a function. Keep it on the side. Now ask the derivative's favorite question about the area function itself. When x slides right, how fast does the collected area grow? Push x forward by a small h. The new area minus the old area is exactly the thin strip we just swept past, nothing more. And that strip is almost a rectangle. Width h, height whatever the curve reads there, f of x. The thinner the strip, the truer this is. So area gained over step taken, the average growth rate, is roughly rectangle area over h. The h on top cancels the h below, leaving just f of x. Shrink h to nothing and the approximation becomes exact. The derivative of the area function is the original curve. This result is important. It says the area machine and the slope machine are inverses. Keep it on the side. Now flip it into a recipe. Want an area under f? You need a function whose derivative is f. Any such function f, called an antiderivative, grows at exactly the same rate as the true area function. So the area from a to b is just f at the finish, minus f at the start. No rectangles, no limits, two plugins, and a subtraction. This is the fundamental theorem of calculus. Now let's look at an application of this concept. Evaluate the integral of 2x from 1 to 3. The theorem asks for a function whose derivative is 2x, and there is a familiar answer. The slope of x squared is exactly 2x. So f of x equals x squared does the job. Keep it on the side. The whole answer now comes from this one function. Finish minus start. F at 3 is 9, f at 1 is 1. The shaded area is 9 minus 1. 8, and here is the satisfying check. This region is a trapezium, and geometry gives its area as 8 too. The theorem agrees with the picture. So the fundamental theorem is not magic. Growing area at rate f is what an integral is, and that is exactly what a derivative detects. Thank you for watching. If you found this video helpful, do like it, subscribe to Math is Beautiful, and share it with your friends.